So now let's look at algebraic expansion factorization. This is very simple. So we have a times b plus c within brackets. So it would be ab plus ac. Then a plus b times a plus d, meaning ac, ad, bc, bd. So you'll have to find the sum of all those. And then we know this law. It's a plus b times a minus b, that would be a squared minus b squared. And then a plus b whole square would be a squared plus 2ab plus b squared. Then a minus b whole squared would be a squared minus 2ab plus b squared. These are very simple, you can remember them. Okay, so now let's move on to exponential functions. So an exponential equation or a function is an equation in which the variable occurs as the part of the index or exponent. For example, 2 to the power of x. Here, the variable x occurs as the part of the index or exponent. We also call this as exponent. So we can write 2x, 2 to the power of x equals 8, or 5 to the power of 2x equals 6. And these are exponential equations. And the way to solve them is, if the base numbers are the same, we equate the indices. So if a to the power of x equals a to the power of y, then x equals y. So for instance, 3 to the power of x equals 27. We can write 27 as 3 to the power of 3. So therefore 3 to the power of x equals 3 to the power of 3, implies that x equals 3. So now try to solve these. I will write down the answers and I'll solve them in front of you. Okay, so now let's solve the first one. So we know that 27 is 3 to the power of 3. So we can write 3x plus 1 equals 1 by 3 to the power of 3. And then using the rule 1 by a to the power of n equals a to the power of negative n, we can write 3 to the power of x plus 1 equals 3 to the power of negative 3. And since we know that we can equate this because the bases are same, we can write x plus 1 equals negative 3, implies that x equals negative 4. So this is our solution. Now let's move on to the next one. We can write 128 as 2 to the power of 7, and then we can write 4 as 2 to the power of 2 equals 2 to the power of 7. Since we know that a to the power of m to the power of n equals a to the power of m times n, we can write this as 2 into 2 to the power of 2 into x plus 2 equals 2 to the power of 7. We can equate the exponents. We can write this implies 2x plus 4 equals 7, implies 2x equals 3, implies x equals 1 by 5 or 3 by 2, which is the same thing. So yeah, that's the answer for this question. And now let's move on to the next one. Okay, this one, we can write 1 by 3 as 3 to the power of negative 1. So we can write this as x plus 2, and 9 as 3 squared, implies negative 1 into x plus 2 equals 2, implies negative x, negative 2 equals 2, implies negative x equals negative 4, implies x equals 4. So this is our solution. Now let's solve the last one. 9 can be written as 3 squared. So 3 squared, 2, this will be 3 to the power of negative 1, 2x plus 1, and then 2 into 2x Okay, so the question was find the value of x if possible. So here, as I solved it, there is no solution. So this won't have any solution. Okay, now let's do exponential functions. The previous slide was supposed to be exponential equations, by the way. So exponential functions, an exponential function is in the form of y equals bx, where b is greater than 0 and b is not equal to 0. Over here we have the graph of y equals 2x. This is the graph. And as x becomes large and negative, meaning it's tending towards negative infinity, the graph of y equals 2 to the power of x approaches the x-axis but never touches it, since it cannot be equal to 0. This cannot be equal to 0. So therefore, however large or small the value of x is, you're never going to get, the y value will never be 0. So therefore, we can conclude that y equals 0 is a horizontal asymptote. We've already discussed about asymptotes. It's where the graph approaches but never touches. So since we have already discussed, I'm not going to go too in depth. Okay, so now let's look at some factors. So for the general exponential function y equals a into b to the power of x minus c plus d, where b is greater than 0 and b is not equal to 0, um, b is not equal to 1 and a is not equal to 0, b controls this value, um, controls how steeply the graph increases or decreases. The greater the value of b, the greater or the more steep the graph is. So if this was b was 2, it would be less steep than if b was like maybe 5. Yeah, and then c controls the horizontal translation. So horizontal translation is left to right, like this way, and vertical translation is this way. So and then d controls the vertical translation. And then the equation of the asymptote is y equals d. So it will look as though it approaches, but it will never touch this line, y equals d. Okay, now let's look at these specific examples. So it would look like this if a is greater than 0, meaning it's increasing, it's concave upwards, it's going up, and then b is greater than 1. And then the graph will be increasing. And if a is greater than 0 and b lies between 0 and 1, it will look something like this. And then if a is less than 0 and b is greater than 1, the function will be decreasing. This is decreasing, this is also decreasing. And if a is less than 0 and b lies between 0 and 1, it will be an increasing graph. Yeah, that's pretty much it for this. So now let's look at some of the graphs. So here, like we have mentioned before, the value of b controls how steeply the graph increases or decreases. So here we can see that y equals 5 to the power of x versus y equals 2 to the power of x. So the value of y to the power of x is increasing more steeply than y equals 2 to the power of x. So over here you can see each and every graph. And that's pretty much it for this chapter. And we're done with this chapter.